Hello, my name is Elijah Porter, and today we'll be making our first video effort on conic sections. All right, so we're given the following problem. The equation is 4x squared plus 9y squared minus 48x plus 72y plus 144, and that equals 0. The first step in this process is we need to get the constant to the other side of the equal sign. So we're going to subtract 144 from both sides, and that allows us to remove the constant, and we end up with 4x squared, because these items simply come down, plus 9y squared minus 48x plus 72y equals negative 144. Excuse me. We then have the following process. I want to group terms that have the same variable. And I'll do that instead of parentheses. So this is 4x squared minus 48x. And then I have an unknown holder here. I'm going to use a question mark to save that. And then I have plus, in parentheses, the terms that have y's. 9y squared plus 72y. And then another placeholder, identified by an exclamation point, equals negative 144. I then want to factor the common term, or the greatest common factor from the coefficients here. I end up with a 4 that comes out, and 4 times x squared gives me 4x squared, minus 4 times negative 12x gives me negative 48x. And I still have my placeholder here. Plus, and here I want to factor out the greatest common factor, which will be 9. So I have my 9 here, and then 9 times y squared gives me 9y squared, plus 8y here, because 9 times positive 8y gives me 72y, and then again my placeholder. And that equals negative 144. Now, the procedure that we need to fill out here complete in order to identify what this question mark value is, as well as what this exclamation point value is called completing the square. So what will happen is, I'll maintain my greatest common factor on the outside, x squared minus 12x. And what we're going to do is we need to take half of this linear term. Now this is the linear term because its exponent on this variable is an invisible 1. I'm going to take half of the linear coefficient. And again, the coefficient is the number in front of the variable. And we're going to take half of that. So I'm simply going to do negative 12 divided by 2. And then I'm going to square that. And I'll write this inside brackets so that you can keep up with what's the parentheses now. And I'm going to repeat the same procedure for this next set of terms, plus my greatest common factor of 9, and then my bracket of 9y squared rather, plus 8y, and then I need to locate the linear term in this polynomial, which is here, 8y, because the letter y has an invisible 1 as the exponent, and I'm going to take half of that, so positive 8 divided by 2, and then I'm going to square that. It allows us to complete the square. And then this equals negative 144. Now let's simplify this, and we'll end up with 4 and then bracket of x squared minus 12x plus, and negative 12 divided by 2 is negative 6. We'll square that and get 36. Repeat the same process here, plus 9, and then my bracket of y squared plus 8y plus, and then 8 divided by 2 is 4, and then you square that and get 16. Close my bracket equals negative 144. Now, the spot where we are now requires some ingenuity here, because we've noticed that we've made changes to the left side of our equal sign. And in basic algebra, we understand that whatever we do to one side of an equal sign or an equation, we must do to the other side. So because we've included these new components on the left side of the equal sign, we must also include them to balance the equation. We need to include them on the right side of the equal sign. What is typically done is a student will simply add 36 to the right side, and then add 16 to the right side. But that's a problem, because what we're really adding on the left side is not just 36, but the 4 times the 36. We're not simply adding 16 here, we're adding 9 times the 16. So this 4 that's been factored out actually has to be included when we identify how to balance the equations. So watch what happens as I balance this out. I'm going to maintain my 4. The bracket here is still x squared minus 12x plus 36. Close my bracket, plus then my next polynomial, which is 9, then a bracket of y squared plus 8y plus 16. And now I'm going to, here's my negative 144, but now I need to add, and I'm going to add 4 times 36, which is actually 144. And then I'm going to add this other term, which is 9 times 16, which also just happens to be another 144. Now, my equation is balanced now. What I included, the 36 represents the question mark, this 16 represents the exclamation point. What I've included on the left side of the equation now has been incorporated on the right side to maintain a balancing of the equations. Now I'm going to simplify this first bracket, and going through the process of factoring again, I end up with 4, and then I have x minus 6 all squared. If I multiply x minus 6 times x minus 6 and do the distributive property, I end up with x squared minus 12x plus 36. Because negative 6 plus negative 6 gives me negative 12x, and then negative 6 times negative 6 gives me positive 36. Repeating the same process with this next polynomial, I end up with 9, and then I have times parenthesis, and I end up with y plus 4 all squared. And that's going to equal, and again, this is because y plus 4 times y plus 4 gives me y squared plus 8y plus 16. Another way of looking at it is 4 plus 4 gives me 8, and then 4 times 4 gives me 16. And then here we need to simplify the right-hand side, and that simply gives me 144, because negative 144 plus 144 cancels to 0, which leaves me with the remaining 144. So right now what we've done is we've converted this long standard form for a conic into its simplified factored form. And now what I'll do is I'll identify why this is important. And I'll continue this process in this space for lack of space. So instead of simply being our tabular location, I'll call it numerical part 2, numerical part 2. I'm going to take this and move it up here. So now we have 4 times, and we have x minus 6 all squared, plus 9 times, and we have y plus 4 all squared, and that's going to equal 144. Now what we need to do is we need to set this equation so that it equals 1. Well, right now the equation equals 144. So what we're going to do is we're going to divide the entire equation by 144. And in doing that, the equation will then equal 1, because 144 divided by 144 equals 1. So we have here 4 divided by 144. 4 goes into both. 4 goes into 4 one time. 4 divides into 144 36 times. And I still have my x minus 6 all squared. And then I have, well, let me allow that to be written better so it's easier to keep track. I simply have 4 divided by 4, which is 1. And I maintain my x minus 6 squared, and then 144 divided by 4 is 36. And then I have here 9 divided by 9 is 1. Here's my y plus 4 all squared, and then 144 divided by 9 is 16. And that equals, again as we discussed, 1. So now I have an equation that equals 1. This is one of the qualifying dynamics for conic sections. And so now what we have to do is we're going to rewrite the 36, the denominator of 36, and the denominator of 16 in a square process. We're using an exponent. So we end up with x minus 6 divided by 6 squared plus, this is x minus 6 squared. And then we have here y plus 4 all squared divided by 4 squared equals 1. So this is the final form that we want. In this form, in case you can't tell from this form, in this form, you should be able to identify which conic section this is. All right? Because there are denominators here, this is not a circle. Because there's a plus sign here, this is going to be an ellipse. So now we know that this is going to be an ellipse. And the dimensions for the spreads on the horizontal axis and the vertical axis are identified by the denominator. Now, so we're going to work that process out. Now, graphically what we have here is that, again, I have this equation. I'm going to write this equation here so that we have it. We have x minus 6 all squared divided by 6 squared plus, and we have here y plus 4 all squared. I'm going to change this title so that it's easier to write. This is the graphical space. We have y plus 4 all squared divided by 4 squared equals 1. Now from this information, we know that the center of our ellipse is going to be that number and this number, the numbers that are inside the parentheses. Because of the subtraction sign here, we're going to use the opposite representation. So since this says minus 6, we're going to use positive 6. Because it says plus 4, we're going to use negative 4. So the center for this ellipse is 6 comma negative 4. The vertex or the vertices on the major axis, and we'll discuss that in one moment, on the major axis are represented by 6 plus or minus 6 comma negative 4. Now the major axis is the axis that the ellipse is stretched along. In this case, because this value, this denominator has a larger value, 6 is greater than 4, or you can say 36 is greater than 16, this axis here identifies the major axis. The variable that's attached to that axis is x. X represents the horizontal axis. So the horizontal axis becomes our major axis and is identified and represented by the value 6. So the center is 6, and now we need to add and subtract another 6 so that we can get the right location for the vertices. And now we must do the same process for the vertices, and vertices simply means connection point or points of intersection. Vertices on the minor axis. Well, because the horizontal axis was the major axis for this problem, the minor axis will be the vertical axis. And again, that's represented because this denominator is smaller than this, and the variable in this fraction is the letter y, and y represents the vertical axis. So we have here, now we're moving up or down, so it does not change the location. So we have 6, comma, and then we're going to be moving the negative 4, or adjusting from the negative 4, so negative 4 plus or minus 4. All right, and that plus or minus 4 becomes from this value of the 4 in the denominator. Now, our foci, or the focus locations, which is important for physics, the foci, which is the plural focus, is represented by this equation, which looks very much like the Pythagorean theorem, but it is not the Pythagorean theorem, a squared minus b squared. All right, our letter A is that number 6, the letter B is this number 4, so we end up with this, c squared equals 6 squared minus 4 squared. And then this ends up being c squared equals 36 minus 16. Continues with c squared equals 20. And we now need to solve for c, because now we have c squared. And the way you do that is you do the opposite operation from exponents, which is radical. So this ends up being c equals the square root of 20. However, this is not in simplified form. And you end up with c equals 2 times the square root of 5, because square root of 4 times the square root of 5 gives us the square root of 20, and then square root of 4 is simply 2. Now, so our coordinates, and then this approximately equals 4 and 5/10. And so therefore our foci coordinate will be 6, and because we're dealing with the major axis, we're going to be adjusting on the major axis, so 6 plus or minus 2 times the square root of 5 and we're not moving up or down, so we maintain the -4. All right, now I'm going to draw this shape in this space here, and so we end with, it looks like this. And then when we have this, it's going to be in the 4th quadrant. So we have 1, 2, 3. We have to go all the way out to 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you label our marks. 5, 6, 7, 8, 9, 10, 11, and 12. That's the horizontal direction. In the vertical direction, we need to go down to the -8. 1, 2, 3, 4, 5, 6, 7, 8. -8, -7, -6 as we label our marks. -4, -3, -2, and -1. And as you know, this is the origin. I use 0 or O for the origin. All right, so we got to plot this. So we have 6. I'm sorry, the center is at 6, -4. So 6, -4 is approximately there. That's the center. Now we need the vertices on the major axis. So I'm going to take care of 6 plus 6, which gives me 12. So then I have 12, -4. So 12, -4 is approximately there. And then I have to handle 6 minus 6. So 6 minus 6 is 0, and then I still have my -4, so 0, -4 is approximately there. Now I need to do with my minor axis. Minor axis is going to be 6, because now we're moving up and down in this case, so I stay at 6. And now I need to do -4 plus 4. Well, -4 plus 4 is 0, so I'm at 6, 0, which is right about there. And then I need to handle -4 minus 4. So -4 minus 4, or -4 subtract 4 is -8. And so that gets me right about approximately there. And when I connect my dots, you'll see how the shape is stretched. Now these should all be curves. This is a flat board, my hand shakes, and I'm not a good drawer. So you can see that this looks more like angles, but these should all be curves, and you see it stretched in the horizontal direction. It's longer in the horizontal direction than it is vertical. That's why the horizontal direction is called the major axis, and in this case, the minor axis is the shorter axis. That's why it's the minor axis. The vertical is shorter than the horizontal as it relates to the ellipse. All right, now we need to handle the foci. So I have 6 plus 2 times the square root of 4. So this should really be, as we discussed, 4.5. So let me make this correction so it's easier for us to compute. So 6 plus 4.5 is 10.5. So I want 10.5, -4, which is right about there. And then I want 6 minus 4.5, which is about 1.5. And I'm still going with -4. So 1.5, -4. Notice that the foci, or the points of focus, the focus locations for the ellipse, are along and will always be along the major axis. In this case, the major axis is going left to right, or the horizontal direction. That's why we see that the foci is along the horizontal. So this is the completed image of this ellipse that came from this typical form for an ellipse that was generated by us working from the standard form for the ellipse. And as I mentioned before, it is quite possible that you can tell that this is an ellipse just from this original equation, but you have to learn and know how to interpret it. If you don't, you must complete the square, which is this process here that results in the equation that we finally have, that we were able to draw. That concludes our session on conic sections for the day. You have not only the circle and the ellipse, you also have the hyperbola and the parabola as the major conic forms that students are required to understand. Thank you for your time.